Okay, we're here to another integral from the UNSW Integration Bee 2023. This was problem 16. We have the integral from 0 to pi of the ceiling of the floor of sine x dx. Okay, this is actually a really quick problem. I would say this is actually a 1 second integral, but it's probably going to take me a little while to explain it. For my first step, what I'm going to do is I'm actually just going to delete this outer ceiling function. And let's go over why. We have our definition for the floor over here to the right. The floor of x is the greatest integer less than or equal to x. And let's just look at an example. Like if my x value is 3.217, let's say. Well, the floor of this is just going to return the greatest integer less than or equal to this, which in this case is going to be 3. And we notice this function always returns an integer, like in this case 3. If after reducing this thing with the floor to 3, if we take the ceiling on it, we take the ceiling of 3, that's going to be just 3. Or if we take the floor on 3, that's just 3. Or we can do it as many times as we want, because these functions always just return integers. So it's kind of a funny problem, is no matter how many times we do this, it just returns the same integer value. And so that's what just allowed me to delete that extra ceiling function, or if they gave us 5 ceiling functions, we could just delete them as they won't change the value. Okay, now for my next step, I just want to look at a graph of sine of x between the values of 0 and pi. So let's just take a look at that. Okay, now here's our graph of sine of x between 0 and pi. You notice at the value of 0, sine at 0, 0, sine at pi is 0. And then for all these values in between, we have everything's going to be between 0 and 1 except for this 1 point at pi over 2. So now if we just look at the value of the floor of sine of x in this region, you'll notice all these values between 0 and 1, the floor is going to take us down to the greatest integer, which is going to be 0. So for all these values here, we're going to get reduced all the way to 0. And then we're going to have like a hole in our graph right here, because at this 1 point at pi over 2, sine at pi over 2 is 1. So the floor is just going to leave us at 1 right there. And then after pi over 2 to pi, all these other values are going to be, the floor is going to take us back down to 0. So we essentially just have a line at 0, and so we're integrating in this region and everything's 0. So we just have this 1 point at pi over 2 where we're not at 0, but because there's no width, it's only 1 point, there's no area at this point. So the area under this curve is just going to be 0, and so the answer for our integral is just 0. Okay, so we'll stop it there. Thanks everyone for watching. Have a great day.